Alright, so just like the other two linked list videos, if you really want to learn circular linked list, just type this out and we'll get started. So right now I just made these, so I should probably put the names in here. Right, and these are just 3 nodes. I'm just gonna put an A here. Name should be Bob. So just put a B here. Name equals Carolyn. So C. Cool. And if you remember from last video, we had a next and a previous pointer. Now, if you really think about it, you could have a node pointer potato, node pointer. Like, you could have a billion different node pointers here, right? And you would have arrows going all over the place, every which way, and yada yada. So you can really make whatever type of list you want. We just call them single and double, so it kind of makes sense of how they probably should be structured, but they don't have to be structured like that in any way. So to make singly linked lists, the probably in my opinion the easiest way to explain them, at least for me, is to just have a next pointer. So I'm going to get rid of that previous pointer from before, and so we're going to put in a next in all of these, right? And this, if you notice, first dot next is going to be second, which its memory address is x98. So there you go, and then put next in here, which should have x42 from third down here. And if you notice, third points to nothing, so normally in there I'd write a null, right? So you can draw these little pointers out, right? What happens when I do this? When I put third dot next equals at first, right? Now what we can do, come on, there we go, is this should be getting this 0 0, right? X 0 0, and now points here. Circular linked list, as simple as that, right? We just have a circle. So if we try and make a pointer to the first one, so, and if you notice, if you think about like our third project, right? We had euchre players sitting at a table. And if you remember, they're in an array, and an array is nice for lines, right? So we had our 4 players at a table. It's nice for lines because you can move down the line, right? But it's not super awesome to start back over. You had to modulus it, or however you did it, you rotate the players. But as you notice, a list works very nicely like this. A circular list, if we had 4 of these, we just point the first player at the second, at the third, at the fourth, right? And you never really have to worry about it, because if you notice, when we do this, we have a node pointer cur node, sure, equals at first. And let's say we see out cur node name and L, and then we do cur node and we move it, right? Equals cur node next, right? And we do this print again, and I'm purposefully not putting this in a while loop. So if we go over here, yeah, I'm gonna move this over here so you can kind of see it. So if we make, and let's see here, what's up? Did you mean to call? Oh wow, lol. That's what happens when you make 3 videos in a row. All right. There we go, make /a, and you notice we can run through this real quick. We got Alice Bob, right? So just like from before, we have our root, and our root, or our cur node, was pointing here, then it moves to the next one, so it moves over there. If we move it again, it gets to go. If we move it one more time, cur node equals cur node next. Now we'll end up getting this third, right? And the cool thing is if we move it one more time, so I'm just gonna copy this all over again. Do it a few times. And it's just a circle now. So move this back over so you can see it. Make .sachet. And Alice, Bob, Carolyn, Alice, Bob, Carolyn, go in a circle. So in Euchre, that would have been very nice to have, right? Now the problem is, when you chuck one of these into a while loop, how are you supposed to know where you started? So while cur node, just like we were doing from before from the challenge problems. And do this. What is going to happen? And let's do back over here real quick. Alright. And it's gonna be really nice and pretty, and woo! Goes in a circle forever, right? So my challenge to you for a problem would be write a function that prints out all the list and sees if it is also circular and stops when it's circular. And I'm going to write it out, but I'd highly recommend pausing and trying to do it yourself. It should help you with the exam. And let's see here. So call it up here. Get rid of this. And we can call this. I'm going to get rid of the drawing just for now. Void. I'm going to call it is circle. And node pointer. Actually, I'm just going to have it return if it is a circle or not. So node pointer, cur node is probably a good name for it. And let's move the node like we have been before. Cur node, or checking that it's not good. Cur node next. Cur node equals. Okay, so that will keep moving it, right? But we need to know if we've seen a node before. If we go back to this and say we start here and then we move around and we keep moving around, when we come back here, when our current or our root or whatever comes back here, we want to check and see if anything that we're on currently we've seen before, or else it'll go forever. So we can get rid of this. And a good way to probably do that is a node pointer first seen equals cur node. And then what we can do is if cur node equal first seen, return true. And what will end up happening is whenever it sees that first one, right, over, it'll just return and break out. And if it's null, then we know the list was just a straight line, right, and ended at a null point. So then we know it's not circular, so we can return false. And one other challenge problem that I'm not going to do actually, but I think is a really cool thing, is what happens if you have a list that looks like this. If you have a list with elements in it, right, like this, a few elements, right? What happens when we have a list that's pointing like this, but then we get it to point back here, and it circles here, but the first thing's not a circle. So in our thing, we only check for the first node here, right? So this will never re-see the first node, and this will infinite. So my challenge to you would be try and write one for that. There's many, many different ways to do it, and they're all really cool. All right, thanks.